Alright, it's time for the solutions for the side congruence assignment. On this entire first section, you're just saying if the two triangles are congruent. You have to say how you know which, if they're congruent. It's probably because you know that you have side, that you have three pairs of sides that match. So if you look at one here, these two are congruent. And you know that by side. And let me explain. We have this side here, which has one tick mark, and this side here that has one tick mark. And then we have this side that has two, and this side that has two. And then these sides here that have three. Since they match on both triangles, so the three sides of one triangle are the exact same length as the three sides of the other triangle, these two triangles are going to be congruent. You can't change the angles if you put those sides end to end. And that brings us to 2, which is going to be yes, because of the same reason. It's all by side. But if you move to 3, this one, it has one pair of congruent sides and another pair of congruent sides, but it doesn't show a third one. But you can add some tick marks here in the middle, because this side is shared by both triangles, this bottom one and this top one. Since it's shared on both, that's a reflexive property that lets you add that. And so this one is also going to be congruent, yes, by side. And that brings us to 4. On 4 we have a pair of congruent sides, and we have a pair of congruent angles. And if you do your reflexive property, you can add that tick marks there in the middle. But we do not have side. We have no idea if these two sides are in fact congruent. And so this one would be no. And then on 5, we have 3 pairs of congruent angles. That does not guarantee congruence. This one's going to be no. And you think about an equilateral triangle. All the angles are the same. Every equilateral triangle has the same angles, are all 60. But you can make it big, you can make it small, and they're not going to be congruent, not guaranteed to be congruent. And that brings us to 6. We have these pairs of sides, and then the pair in the middle that's congruent by the reflexive property. So 6 is going to be a yes, because we have side. And that brings us to the next section. When you state what additional information we need in order to have side. So on 7, we know we can add a tick mark in the middle because BD is congruent on both triangles because they share that side. And then we have these top and bottom sides congruent. We need another pair of sides to be congruent, namely this side and this side. And so that's what we're going to write down. We need DS, side DS, to be congruent to the side BC. So we need those to be congruent. And you just write that down. That's what we need still. 8, these sides are already congruent. You can add your tick marks there in the middle because they share the side. And now we just need these last 2 sides to be congruent in order to have our side. So we need DC, segment DC, to be congruent to this segment TC. And then on 9, we have these 2 sides matching up. And we just need these last ones, XZ and US, to match up. And so we're going to write that down. US, segment US, go US, needs to be congruent to XZ. Just like that. We need those to be congruent. We don't know, but we need that. On 10, you can add your tick mark there in the middle because UW is congruent to UW by the reflexive property. These 2 sides are already congruent. We need the remaining sides to be congruent. We don't know that yet, so we need to add that. So VU needs to be congruent to BU. And then the next 2, we can add our little tick mark there in the middle because that side is shared by both triangles. These sides are congruent there, so we just need the remaining sides to be congruent. So we need the segment LM to be congruent to the segment FK. And then 12, we have our two pairs of segments, FE congruent to ML, and then MN congruent to FG. And we just need the last sides to match up in order to get congruence. So if LN was congruent to EG, the segment EG, then we would have congruence by side, side, side. And that brings us to our last section. So we need to write a proof that can be used to prove congruence. So I'm going to add some labels here. We got A, B, C, and then I'm going to have my corresponding ones D, E, F, and I'm going to start with my givens. So I'm going to make actually a couple columns here, and I'm going to include the proof part, or the reason, and then this side is our conclusions. So something I know right away is that AB is congruent to DE, and that's given. That's right in the figure. So I'm going to put given down, and then I got BC congruent to EF. And that's also a given. It's right in the picture. And then lastly, we have AC congruent to DF. And that's also a given. That's all given right there on the pictures. And so I know that triangle ABC is congruent to triangle DEF by side, side, side. And that's my two-column proof there. And that brings us to 14. Again, I'm going to add me some, there, let's change out the letters. We'll have Z, K, T, and G, because I like adding new letters. But I can do the same sort of thing. I know that ZT is congruent to the side GT. And I know that ZK is congruent to the side GK. And let me put those down first. So those are my first two conclusions. My proofs over here on the right side include given and then given. They're both given, so right there on the picture. Something we can add, though, is right here. I know that KT is congruent to sub. It's congruent to KT. And that's because of the reflexive property. Just everything's congruent to itself. So that's that congruence there. And then the last part, these two triangles, ZKT is congruent to triangle GKT. And that's by side, side, side. That brings us to 15. Let's see, Q, N, and H. And then I like Z. Put Z in there. I'll throw some X in there, and let's do M. So we got our vertices. Just label them real quick. I know that QN is congruent to, so this side is congruent to this one. That's ZX. And I know that because that's a given. And I know that NH is congruent to XM. That's also a given. It's right in the picture. And then I know that QH is congruent to ZM. So those two sides are the same. Because that's also given. And then the last part, you guys say that they're congruent because we know that by side, side, side. If the sides match on the triangles are going to be congruent. So you got QHN. And when you list these vertices, make sure you do it in the same order. So when you come here, you're going to do it in that order, Z, N, X. And that one's good to go. And we just got one more. Let's put T here, and Y, and P, and B. Right now I know that TP is congruent to BP because of those lines there. So I got TP is congruent to BP. And I know that because that's a given. And I know that TY is congruent to BY. Because that's also given, it's just right on the figure. One thing that's not given is right here in the middle. We have PY is congruent to itself, PY. And that's because of the reflexive property. Everything's congruent to itself. Here, I'll even write out property. And now I know that triangle TPY is congruent to triangle BPY by side, side, side. So there you go. Even the proofs on the end, all in one video for you.